So welcome everybody to this latest video on 162 Maths, and in this video we'll be continuing with the higher GCSE topic of rate of change with the focus of looking through some past exam questions. Now, as always, a reminder, there is a copy of the questions in the description below, so if you want to have an attempt at these questions before watching this video and going through the answers. Now, before we have a chance to go through some of these past exam questions related to rate of change, just a little reminder that if you wanted to have an attempt at these questions before continuing watching this video, then all you need to do is just click on the link in the description below and download the document. So let's go straight into these. So again, rate of change can appear on both the calculator and the non-calculator paper, so it's worth just remembering the technique. And again, one, you'll be able to use a calculator, but I would say it's not essential if a calculator is available to you. So looking at question 1, it says that A and B are points on a curve, and it tells us the coordinates of A and B. And for part A, it says work out the instantaneous rate of change of Y with respect to X at point A. So here, those two coordinates are actually already plotted for us, so I don't need to plot it. I can see A just there. Now what I need to do is I need to accurately draw a tangent at point A. Now again, this is going to be incredibly fiddly on the computer. But if I start now, again, what you want to try and do is imagine that if I just make that a little bit thicker, is you want to try and imagine that you're balancing a stick where the middle of the stick is going to be at point A. And again, this is going to be very, very frustrating for you to watch. And so that clearly is not a good example. So let me go freestyle. So for this, what we need to do is, again, you just want to draw a line that balances that stick there. Now it's really important that you do draw the tangent. That's, again, this question is worth 2 marks, in which 1 mark will be given to you by drawing the tangent. Then from this, what we then need to do is to convert this into a right angle triangle. Now for this, what's also important is you recognize the units of your scale. So here, one little box represents 0.2, and that's going up, and going across, again, the same units, one little box across equals 0.2. So for this, I count that I've got around about 5 squares, and going up, I've got 6 squares. So from this, what I can then do is do 6 times 0.2, which is 1.2, and 5 times 0.2, which is 1. So then all I then need to do is then use these numbers to work out what the gradient is going to be. So the gradient at A, in other words, the rate of change, or rate of increase even, because it's going up, is going to be 1.2 divided by 1, which is 1.2. And then the units aren't mentioned, so I just leave it as 1.2. For part B then says that the average rate of change of Y with respect to X between the points A and B is worked out. Which of these statements is correct? So here what it's doing, it's wanting to work out the rate of change from A to B. Now as you can see, that if with a ruler, if my starting point is A and my end point is B, then all I need to do is to draw a line from A to B. Now looking at this, you can see that from A to B, the gradient just does change, and it goes positive and it goes negative. Now here, if I just draw another sort of line here, that this is where I'm increasing, or the rate of change is increasing, and here is where it is decreasing. So going back to the question, it says the average rate of change Y with respect to X between A and B is worked out. Which of these statement is true? Well, if you're looking at the average, you can see that we're decreasing more than we are increasing. So in other words, we're at more where we've got negative gradient than we have got a positive gradient. So then our correct answer we need to tick is it is negative. Moving on to question 2, it says the table shows the cost of hiring a concrete mixer for up to 5 days. Eva hires a concrete mixer for 5 days. She says that the rate is £14 per day because the cost of 1 day is £14. Is she correct? And the answer is there, as you can see, that she is wrong. So no, after the first day, the rate is £10 per day. Moving on to question 3, it says that a ball is thrown vertically upwards. The graph shows the height of the ball above the ground after it is thrown. And the question says for how many seconds is the ball at a height of more than 2 meters? So looking at the height, what we're looking at here, if I just draw this here. So it's been thrown up in the air and then it has fallen down further below from where it was thrown. So you could imagine, like for example, here is where the hand is. And again, that's a very, very poor hand. And very long legs. And here is the ground. So that's where it's limited. So it's been tossed in the air and then it's been fallen on the floor. So the question said, how many seconds is it over this green line that I've drawn? And you can see there, I would make it out to be around about 3 seconds. And again, I would say that roughly the mark scheme would give any answer between 2.9 and 3 seconds. Question B then says, after how many seconds is the ball at an instantaneous rest when it is in the air? So basically, when is it stopping? So it's at this point here, which is B. And I would say that that answer there is at 1.5 seconds. Now again, in the mark scheme, any answer between 1.4 and 1.6 would get you the single mark. The next question, C, then says work out the average speed of the ball when it is moving downwards. So here what I'm looking for is, this is my start point, this is the end point. So I then need to draw a line from those 2 points. So let's just do just that. Like so. And again, yours will be a lot easier doing this on paper than it is on computer. So I need to work out the gradient of that red line. So let me just get rid of those dotted red lines. So again, from this, if I turn that into a triangle, I can see straight away that that's going to be giving me a negative gradient or a rate of decrease. So looking at the height of this triangle using the scale, it's looking at around about 4.6. And in terms of the seconds, I make it out to be from 1.5 to 3.5. So I then make it out to be 2 seconds. So for here, for C, the rate of increase, or rate of decrease rather, or the rate of deceleration is going to be 4.6, the height divided by the base, which gives me 2.3. And the units of that is going to be meters per second. And again, the mark scheme allows any answers between 2.275 and 2.45. So moving on to question 4, it says that a ball is thrown from a point 6 meters above the ground. The graph shows the height of the ball above the ground in meters, and the question is asking us to estimate the speed of the ball in meters per second after 1 second. And it says you must show your working out. So what we need to do here is first of all mark 1 second, which is here, and then what we now need to do is to draw a tangent at that point. So again, as accurately as you can, to draw a straight line at that point at 1 second. Now from this, what we then need to do is to turn that into a right angle triangle. So again, and again, your triangle will be definitely a lot neater than the one I'm doing on the screen, but hopefully we get an answer that's still applicable. Now again, this question is worth 2 marks, and it is really important that you do show your tangent line. Again, I can't stress that enough. That will get you 1 mark. Even if you don't do it to convert it to a triangle, if you just draw a tangent at 1 that balances on the curve at that point, you will get 1 mark. So the next thing we then need to do is to actually work out what the gradient is. Now each little box going up is going to be, so 1 little box represents 0.2, and going across, 1 little box equals 0.1. So counting the number of boxes going across, I get for this, I reckon it's from there to there, so that's 3 and 7, so that's going to be 0.7, and going upwards I've got about 6 boxes, so that's going to be 1.2. So here the gradient at t equals 1 is going to be 1.2 divided by 0.7, and that gives me an answer of 1.71 meters per second, and that's to 2 decimal places. And again, your answer could be absolutely anything, so as long as you're working out the gradient of your tangent that you've drawn, you're going to get that second mark. Moving on to question 5, it says water is poured into a glass for 4 seconds. The graph shows the depth of the water in the glass. And the question is saying, what is the rate of change of the depth of the water? So again, what we need to do is basically work out the gradient of this line. So if I pick 2 coordinates and look at the triangle, it's got a height of 10 and a base of 4. So it's going to be 10 divided by 4, which is 2.5, which is our third option. Moving on to question 6, it says that the height h meters of a particle at time t seconds is given by the function. And the question saying is to draw the graph to show the height of the particle in the first 10 seconds. So for this, what I need to do is, first of all, zoom out so I can see both the function and the graph. Now for this, what we need to do is use this scale and then use this function to find the y. So here from 0 to 2, h is 0, so that is going to be a flat line from 0 to 2. So what it's going to look like is it's going to look like this. It's going to be on the t-axis. Let me just do that again so it's a little bit neater, like so. Then from this, what I then need to do is use this function. Now for this, I need to use the table of values to find the points. Now I'm going to go for t equals 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm then going to substitute the numbers to work out what h is. So for this, I just show the working out. So here I've got 14 take away 2, which is 12, times 2 take away 2, which is 0, which is 0. And again, all I'm doing is substituting this t value into this formula. So then from this, what we then got is 14 take away 3, which is 11, times 3 take away 2, which is 1, so then it's 11. Then I've got 14 take away 4, which is 10, times 4 take away 2, which is 2, so that's 20. Then 14 take away 5 is 9, and 5 take away 2 is 3, so that becomes 27. Then from this, I notice a pattern. Let me just fill this in, and I can see that these numbers are increasing. And then just working it out, so I've got 32, 35, 36, 35, and 32. And then from this, what I then need to do is plot these coordinates. So 12, 0 is, sorry, 2, 0 is there. At 3, it's 11, which is there. Then 4, 20, which is there. Then I've got 5, 27, which is there. Then 6, 32, which is there. 7, 35, which is there. 8, 36, which is there. And then 9, 35, and 10, 32 is there. And then what I then need to do is then, as accurately as I can, is join those points up. And again, apologies in advance. This will look a little bit podgy. And there we go. So that's how we draw a function graph. The next question then says is by joining the points on the curve, which is what we've done, where t equals 3 and t equals 7 with a straight line, work out the average rate of change of the height between 3 and 7 seconds. So for this, what I need to do is find 3, which is there, find 7, which is here, and I then need to join those points up with a straight line. And again, trying to be as accurate as possible. Now again, I'm using thick lines only because it comes up better on the screen. So here, and again, it's going to be a lot more awkward doing this on the screen. It would have been much easier doing it on paper. I'm joining those points up, and then what I then need to do is work out the gradient of this line. So here the coordinates, well, I'm actually going to use the actual coordinates. So here I've got 3, 11, and I've got 7, 35. So then working out the gradient, it's going to be, I'm going to use y2 minus y1 over x2 minus x1, or in other words, the difference in x over, difference in y over the difference in x. So it's going to be 35 and 7 and 11 and 3, take away, turn into a fraction, in which here I get 24 over 4, which gives me 6, and then the units are going to be, which is not given, well, it's meters per second. And there is my final answer. So moving on to question 7, it says Sam runs for 10 minutes. The graph shows his pulse in beats per minute. And the question's asking us to, by drawing a tangent, work out the rate of which his pulse is increasing after 3.5 minutes. Give your answer, or give the units of your answer. So for this, what I need to do first is to plot where on the curve is t equals 3. So at t equals 3, without it burning my eyes, is about there. So that's where t equals 3. Now what I then need to do is draw a tangent. Now again, you need to always make sure that you're drawing your tangent. So again, you want to draw a straight line which balances on the curve at where that red point is. So again, just be very, very careful, and you draw your line there. Once you've drawn your tangent at t equals 3, you then want to convert that into a triangle, and then use the scale to then work it out. So looking at this, I get that to be about 6 squares, and this is about 3 squares. Now looking at the scale, so that's 6 squares and 3 squares. So looking at the scale going up, so the gradient at t equals 3 is, well, each little square going up represents 1, so that's going to be 6. And going across, well, one little square represents 0.2, so 3 times 0.2 is going to be 0.6, so I get 6 over 0.6, and if I do that on my calculator, 6 divided by 0.6 gives me an answer of around about 10. And again, I would say, although the answers in the mark scheme say an answer between 9.4 and 9.8, it does give you follow-through marks for as long as you've worked out the gradient of the line you have drawn using the correct scale. Now for this, you also need to state the units. So here again, looking at this, we're looking at beats per minute. Oh, no, don't know where I've put an I there. So it's beats per minute, which is then going to give me beats per minute squared. So looking at question 8, it says the diagram shows an empty container of height 21 centimeters. The container consists of a cylinder on a frustum of a cone. Water is added to the container at a constant rate of 11 seconds, and the sketch graph shows the depth of the water as the container fills. The graph is a curve for the first 6 seconds and a straight line for the next 5 seconds. And here we've got a graph which again is not drawn accurately. The question says circle the height of the cylinder. Now if we look at the actual container, you can see that it's a frustum first, then the cylinder. So this bit here is the frustum, and this bit here is the cylinder. So then the height is going to be 21, take away 13, which is 8, which is my first option. The next question then says, work out the rate of increase of the depth of water between 6 seconds and 11 seconds. State the units of your answer. So if I highlight the 6 seconds and 11 seconds, it's asking me to work out the gradient of that blue line. So again, converting that into a right angle triangle, the gradient is going to be the distance up, which is 8, over the distance across, which is 5. Then the gradient is therefore going to be 8 over 5, which is 1.6. And then the units are going to be centimeters over seconds. And again, if you're not too sure about the unit, it's always the y-axis over, because obviously it's y. This is the y, which is centimeters, over time, which is in seconds, so it's centimeters per second. Moving on to our last example, it says a container is filled with water in 5 seconds. The graph shows the depth of water d centimeters at time t seconds. And the question is asking, the water flows into a container at a constant rate. Which diagram represents the container? So looking at this, the one that you should have, so it starts up fast and then slows down. So it's going to be option C. Then for part B, it says use the graph to estimate the rate at which the depth of the water is increasing at 3 seconds. So going back to the graph, what we need to do is mark at point where it's 3 seconds, which is this point here. And then what we then need to do is draw a tangent at that point. And then we then need to work out the gradient of this point here. Now just be mindful of the scale and make sure you're using the scale. So looking at this, one little box going up represents 5 divided by 10, which is 0.5. And looking at the distance across, one little box represents 0.1. So again, as long as you're working out the gradient of your particular point, then that is going to be absolutely fine. And again, looking at the mark scheme, I think they're accepting any answers between 3.6 and 4.4. But let's have a look at what we'd get here. So looking at this, I count around about 2, 5, 7, 8 squares. So 8 squares up. And going across, I probably make that out to be about 1. So 8 times 0.5 is 4. And 4 divided by 1 gives me an answer of 4. And then the units are going to be our y-axis units, which is centimeters, over our x units, which is seconds. So it's going to be 4 centimeter squares. So, but again, as you can see, any answer between 3.6 and 4.4. And again, do not forget the units of this question, because again, with it being 3 marks, you'd get 1 mark for the calculation of your tangent, 1 mark, and then obviously for working out there, and then 1 mark for your answer, and then 1 mark for your units.